Hello friends, we are going to start the fourth unit of the surveying, that is tachometric surveying. What is tachometric? How it is the changeover? Here the telescope's crosshair going to play a major role. How they there are some crosshairs and extra hairs are there. We are going to use that also, since it is a manufacturing constant. We can utilize that also, and based on that we can directly get the distance of the between 2 points with the help of these concept, such that I can avoid the usage of chain or tape. Even by using the theodolite, if the crosshairs are available, it can be used for the tachometric principle. What are they? Let's see one by one. Tachometric surveying, tacheometric or telemetry is a branch of angular surveying in which the horizontal and vertical distance of points are obtained by optical means, as opposed to the ordinary slower process of measurement by tape or chain. This is the main definition for tachometric surveying. This method is very rapid and convenient. It is best adapted in obstacles such as steep and broken ground, deep ravines, stretches of water or swamp, and so on, which making chaining difficult or impossible. In that area, it is more apted. The primary object of tacheometry is the preparation of contour maps or plans requiring both the horizontal as well as vertical control. Also, on surveys of higher accuracy, it provides a check on distance measured with the tape. So here the tacheometry is a Greek word which means quick measure. It is a system of rapid surveying by which the position, both horizontal and vertical, of point on the earth surface relative to one another are determined without using a chain or tape or a separate leveling instrument. So the uses of tacheometric. The tacheometric methods of surveying are used with advantage over the direct methods of measurement of horizontal distance and differences in elevation. Some of the uses are preparation of topographic maps which require both elevation and horizontal distances, survey work in difficult terrain where direct methods are inconvenient, detailed filling, reconnaissance surveys for highways, railways, etc., checking of already measured distance, hydrographic surveys, establishing secondary controls. Right? These are the areas where the tachometric plays a major role. What are the instruments required for it? An ordinary transit theodolite fitted with a stadia diaphragm. Already I have shown the stadia diaphragm, the telescope fitted with the crosshairs and extra hairs is generally used for tachometric survey. The stadia diaphragm essentially consists of one stadia hair above and the other an equal distance below the horizontal crosshair. The stadia hairs being mounted in the ring and on the same vertical plane as the horizontal and vertical crosshairs. Stadia is a tachometric form of distance measurement that relies on fixed angle intercept. This is the concept we are going to use it. See, the main line shows the crosshair, horizontal crosshair, vertical crosshair. These two are on equidistance from the center. In all the things they are equidistance, right? So these are the variety of telescopes having variety of crosses, but we are going to use the distance between those things, right? So this becomes the top stadia hair, this is the bottom stadia, this is central crosshair, right? And these distance will be constant for the telescope or the particular instrument manufactured. That concept we are going to use it. These are different forms of stadia diaphragm commonly used, right? The telescope used in stadia surveying are of three kinds. The simple external focusing telescope the external focusing analytic telescope or Porsche's telescope, the internal focusing telescope, right? A tachometer must essentially incorporate the following features. The multiplying constant should have a nominal value of 100 and the error contained in this value should not exceed 1 in 1000, right? The 100 may vary plus or minus 1 in 100. The axial horizontal line should be exactly midway between the other two lines. The telescope should be truly analytic. The telescope should be powerful, having a magnification of 20 to 30 diameters. The aperture of the objective should be 35 to 45 mm diameter to have a sufficiently bright image. For small distances, say up to 1000 meters, ordinary leveling staff may be used. For greater distance, a stadia rod may be used. A stadia rod is usually of one piece, having 3 to 5 meters length. The stadia rod graduated in 5 mm, that is the least count of the leveling staff is 0.005 meter for small distance, and while for longer distance the rod may be graduated in 1 centimeter, that least count is 0.01 meter. Let's say now here the instrument look like a dumpy level, but in this case we can attach the theodolite and we are seeing the leveling staff and the crosshairs will fall like this. See our metric leveling staff here from 0 to 1 meter graduation I have shown here. In that, if we see a particular spot on the leveling staff, say it crosses over this line and this line and here this line, right? So the crosshair, bottom stadia hair touches the particular line in the leveling staff. Say here this point is 0.6, then this is the 0.5 here, and from 0.5 this is 0.51, 0.52, 0.53, and it is 0.535. So this the bottom reading is 0.535. Here it is 0.65 and it is bottom of the black, so 0.655 is the central cross reading. Similarly here it is 0.75, 765. So these three readings we have to note down, right? So these three readings we have to know. So top, middle, bottom, these three readings we have to utilize for any set of reading in the tachometric principles, right? Different system of tachometric measurement. The various system of tachometric survey may be classified as follows: the stadia method, tangential method, measurement by means of special instrument. This we are not going to concentrate. We are going to concentrate the stadia system and the tangential system. In the stadia system, again it is divided into fixed hair method of stadia method, movable hair method or subtence method, right? In this one we are going to concentrate predominantly more, and tangential method, right? So the principle common to all systems is to calculate the horizontal distance between 2 points A and B and their distance in elevation by observing the angle at the instrument at A subtended by a known short distance along a staff kept at B and the vertical angle to B from A, right? This is the principle we have to adopt. Then what is fixed hair method, right? In this method, the angle at the instrument at A subtended by a known short distance along a staff kept at B is made with the help of a stadia diaphragm having stadia wise at fixed or constant distance apart. The readings are on the staff corresponding to all the three wires should be noted down. The staff intercept, that is the difference of the reading corresponding to the top and the bottom stadia wise will therefore depend on the distance of the staff from the instrument. When the staff intercept is more than the length of the staff, only half intercept is read. For inclined sight, readings may be taken by keeping the staff either vertical to the line of sight or normal to the line of sight. This is the most common method in tacheometry, and the same stadia method generally bears reference to this method. And subtence method, tangential method. In subtence method, this method is similar to the fixed hair method, except the stadia interval is variable. Suitable arrangement is made to vary the distance between the stadia hair as to set them against the two targets on the staff kept at the point under observation. Thus, in this case, the staff intercept, the distance between two targets is kept fixed, while the stadia interval, the distance between the stadia is variable. That is the difference between the subtence and the stadia method. As in the case of fixed method, inclined sights may also be taken. In tangential method, the stadia hairs are not used. That is the difference. The readings being taken against the horizontal crosshair alone, the central one only. To measure the staff intercept, two pointings of the instrument are taken, therefore necessary. With respect to the central crosshair itself, on the particular leveling staff, we try to see one point and another point with the central crosshair alone. Right? This necessitates measurement of vertical angles twice. So I have to make the vertical angle at one point and another point also from one single observation. Right? Now we try to see what is the principle of stadia method. Before that, recap, we have seen tangential method, what it is, what is subtence method, and fixed hair method, right, and the basic principle of tacheometric. Right, we will continue in the next video.